Okay. Hello. Okay. Let's make a start. Thank you for coming. And today is a talk from Andrew Waugh, and I think you must have received my email saying that Andrew is the pioneer in tall timber building, and we are known for all over the world. So I'm very delighted to have Andrew here. So I won't take too much time, so I'll hand over to Andrew. Thanks.
Excellent. Thank you very much, Wen-Shao. Do you want your coffee?
Yeah, I will get my coffee
And your water. Okay. Right. Yeah, thank you. Hi, everyone. So we're Waugh Thistleton Architects. We're a practice in Shoreditch in East London. And that's Fran. She went to Bath. And I think a couple of other people did as well. Anyway, so we are a practice that build mostly in timber. And the reason why we build in timber is about climate change. It's about greenhouse gas emissions and carbon dioxide emissions, and about the impact that construction has on climate change. So just really simply the sketch, the originator of all the work that we're doing now and everything that we're excited about really comes from wanting to take this on board, wanting to really if you accept the notion of climate change, which I do, and I'm assuming that most of you do, then the idea that as architects, our architecture carries on almost regardless. You know, we keep on building like Zaha or Leaf Skinned or Gehry, but we put solar panels on the roof. The idea that would be what this climactic event, what this terrible event, what this terrible issue surrounding us, what that did to our architecture, what that did to the architectural expression of contemporary culture, to me, was a nonsense. So, and that idea, faced with the notion of a world housing crisis, the idea that actually we're moving from a largely agrarian world culture to a largely urban world culture, the idea that we need to sort of start housing billions of people in the next few years. In the UK alone, I mean, it depends which political party or which magazine you read, but so between 200,000 and 300,000 people a year, and 300,000 homes a year, and last year we built 110,000. So we're kind of like, there's lots of work to do, lots of houses to build, and we need to build them in such a way that we don't contribute to climate change, but that we help mitigate climate change. So this is us in 2003. And we're a bit smaller then, and we built mostly, as you can tell, I'm sure we built mostly nightclubs and restaurants and house extensions and kitchens and that kind of thing. And we started, and in 2003, the first set of planning guidelines came out in terms of environmental awareness, and eco homes it was called. And eco homes said that if your building wasn't near a bus stop, then you would need double glazing. However, if it was near a bus stop, you'd be okay. Now, as an approach to climate change, that struck us as rather sort of short-sighted. And the idea that somehow that this would, that they were just small changes that we could make, but this massive impending problem coming toward us seemed to us fairly ridiculous. So we started to dig a little deeper and think about not just energy use, but also the building materials that we built with, the process of construction, how that worked, what kind of impact that was having. Now, if you go back to this one, a third of all greenhouse gases are caused just by concrete, just by the production of cement and concrete. So cement was the one thing that the International Protocol on Climate Change called out as being a major contributor to greenhouse gases through the use of energy and through the mining of aggregates and of Portland lime. So in 2003, we were looking around for different types of construction materials, for different types of innovative technologies to build with. And a year-out student in the office said to me, that there was this little kind of hippie place down in South London that we should go and check out, and where they had some alternative, construction materials. And so we went down there, and there was the nice lady with her hempcrete, and somebody else with their straw bale technology. Not an urban solution, if you ask me. Anyway, and there in the other corner was the Austrian guy selling what looked to us like jumbo plywood, and with these kind of amazing sketches on the wall behind him showing what could be done with this fantastic new material. And so we took him at his word, and we had this little project, Exton Street, in near Waterloo, which was a nightclub for classical musicians. I've never been back, by the way, but anyway, it's 45 square metre, 2-storey extension to a 17th century building near Waterloo. And it was completely landlocked, so we'd been concerned for some time how we were going to get the building materials through the building or over the building. And upon kind of discovering this material, we realised that actually, this comes out of the factory with the doors all cut out, perfectly measured to size, and we could just crane it in over the roof, and 2 guys could just screw the whole thing together. And on a Saturday afternoon in 2003, we built this 3-storey afternoon, 45 square metres, and I watched it go up, and it was perfect. It was really beautiful. The idea, the notion of the construction process, of the practice of architecture involved in this tiny little building was really, really exciting. And so for the next few years, we researched and designed and interrogated people about CLT. And now this is CLT. I don't know if everybody knows what cross-laminated timber is, but just really, really briefly, it's secondary grade timber from the outside of a pine, usually a pine tree, a European spruce. So the timber from the outside of the tree, the stuff that gets made into paper and cardboard, that gets chipped for fuel, that kind of thing. So really sort of fairly waste product. And what they do is they finger joint long planks of about 75 millimeters by 25 millimeters into long lengths. They lay them out and they spray them with a PVA, so a water-based adhesive. Like the kind of stuff that if you put on your hand and you go like that, it kind of all sort of wrinkles up. So PVA adhesive, and they're laid down in perpendicular layers on top of each other at right angles, and they're built up in layers to the performance that they need to meet, whether they're floor slabs or walls or whatever they are. So less than 1% adhesive, and not a formaldehyde-free adhesive, and nothing else. So just the pine and the adhesive. Now material was invented in Austria in the 1990s because they weren't doing anything with their timber. All the trees that they had were going to seed. And so the word went out from the Austrian government, find something to do with our trees. And so Technical University in Graz came up with this as a notion. A couple of factories were starting to produce this in the 1990s, including this one, which is KLH in central Austria. Now you can see these panels here coming out of the factory at about 16 meters long by 3 meters wide, and anything from about 70 mil thick to about 500 mil thick, depending on what they needed to do. Now you can see all the doors are cut out, roof profile here, window cut out, and in these factories, all the cutouts here go to the biomass generator, and the whole factory is off-grid. So, in fact, in this one, it even powers the village where all the workers live as well. So in 2008, we had been honing this argument and doing lots of research and talking to lots of different engineers. And in 2008, we really had a pretty clear notion of how you build and what you can build with this material. And we got this job in Shoreditch on a council estate in the part of Shoreditch where people don't go, and it was an old pub site, and it was very clear that from an extrusion of the site plan to about 9 stories, that we'd get about 4 flats a floor, and so we'd get about 30 units on the site. So we went to the local authority, and we said to the local authority, we've been studying this material for a long time, and your planning requirement is for us to reduce the carbon footprint of this building by 10%. Now, if we build this building in timber, just the amount of carbon that's stored in the building itself is equal to the amount of carbon that the building will emit for 250 years. So actually, by that 10% reduction is over 250 years, sorry, for 25 years worth of energy use. So we said to them, if we did that, would you allow us to use that calculation as the reduction in carbon as part of your planning policy? And to our amazement, they said they would. So we went back to our client, and having agreed our fee, we had what we began to call in the office over the years the timber chat, which is where we agree our fee, and then we say to them, let's build it in timber. And they say no. And we got quite good at that argument. And we were able to say to them, well, what we've done is we've sketched up a building in concrete and a building in CLT. And we know that if we build it in CLT, it will weigh about a fifth of what a concrete building weighs. It will take about, it will be about 50% quicker to build. It'll be about 15% cheaper to build. We won't need to make any of the other carbon offsets for the local authority other than actually building it in timber. We won't need a tower crane. We can build the whole lot from a mobile crane from the back of a truck. And also, we will be building a building that rather than a concrete building, which let's not forget, a concrete building is not a building made of concrete. A concrete building is concrete floor slabs on columns with usually some kind of lightweight wall structure around the outside. So in effect, what you're doing when you build a concrete building is you build one building made of wood, then you pour the concrete into it, then you take the first building away, you're left with a second building, and then you clad it with the third building. So rather than making 3 buildings, what we can do with CLT is actually make an entire structure from the cross-laminated timber. So that building then is like a honeycomb structure. So every floor slab, every wall, the external wall, the external facade, the lift core, the stair core, everything is made of cross-laminated timber. The walls are about 150 mil thick, and the floor slabs are about 150 mil thick, and the walls are about 120 mil thick. So we were able to, this should be a film. Is it going to be a film? There you go, look. So this is definitely the part of Shoreditch you haven't been to. This is the stairs here, lift core going up here, and the slabs going around. So the Austrians arrived by truck on a Tuesday morning. They put panels up on a Wednesday and Thursday. They worked a 3-day week, and they built a story a week. So 4 people built the entire building in 27 days. So you can see it going up here, no tower crane. So over 1,000 tons of carbon dioxide safeguarded within the timber structure itself, no tower crane. A tower crane cost for a developer, if you talk to them, a tower crane costs about £80,000 a month to hire. And you need to put in special foundations to build a tower crane, for a tower crane to set into. So not having a tower crane is a major advantage to any contractor. So we were able to, obviously, we were able to persuade our client to build in CLT, to build this building in CLT. And and they sold all of the flats in 1 hour and 15 minutes. So this is the internal structure here. You can see this is one of the double height spaces here. This is the building going up. So you can see the whole thing is put together, fastened together with 75 millimeter galvanized shelf brackets and 100 millimeter screws. You can see in the ceiling here, these are the little ties for the electrics. So the electric cabling that runs through the ceiling. The electrician explained to me that when you're an electrician, when you apprentice as an electrician in the UK, you spend about the first 18 months hammer drilling into concrete. And then after about 18 months, your shoulder joint disintegrates. And when it's disintegrated, then they teach you about electrics. So he explained to me that actually the notion of building in these buildings, not just in designing these buildings, but actually in the construction of these buildings, that the contractors, the builders working in these places are safer and happier. It's a better working environment, a better place for a builder to be. So, and much, much faster. So some of the advantages that we hadn't realised that we hadn't calculated in terms of the speed was actually the people that came in afterwards. So all the people that did the dry lining, the plasterboarding, all the people that did the electrics and the plumbing, so much quicker, so much easier to do. So once we had finished the entire structure, we covered the whole thing with plasterboard, which for many people, going from that to that is a bit of a tragedy and a bit, oh, but where's all the timber gone? It's so useful. And I think for us, the idea is, or the mantra was from the very beginning, that we need to demonstrate that timber can be a viable alternative to concrete and steel. That going back to the notion of actually building with a carbon store, that rather than allowing our practice to be a peripheral one, to be one that kind of, you know, those sort of sustainability practices with the kind of, you know, the hair shirt and the kind of, the sort of the buildings that look very kind of like they're sustainable buildings. We didn't want to be involved in that. We've never wanted to be a peripheral practice. We want to be a mainstream practice, working with the big house builders, making real differences to the sustainability and the environmental awareness of how we build all of our homes in the UK, not bird-watching centres or National Trust museums on the outside of town, but actually real understanding. So when we were working through the building regulations, working with our client said to us, we don't want anybody to know that this building's made from timber. And so you're like, fine, not a problem at all. And just a little article in the Evening Standard about it, but apart from that, we won't tell anybody. And the idea of covering it up in plasterboard actually allows us, means that we don't have to paint any of the CLT with intumescent. We don't have to fireproof the timber itself. So actually the life cycle, the cradle to cradle idea, the notion of the timber, is that this material, after its useful life, can be used, can be reused for buildings, can be pulped for paper, can be chipped for fuel. Unlike if you paint the timber with intumescent, and then that goes to landfill at the end of its life. So the idea was that we kept the material as something that was breathable, that was fully recyclable, and that for our fire protection, we looked to plasterboard. Now, the idea that we would be doing that forever and not actually learning as we go, as people, other architects, including ourselves, better understand the way that the system can work, that we won't kind of leave more of it exposed. But when finished, it looks like all the development flats that our developer client was after. And as I say, they all sold in an hour and 15 minutes. So going back over the job, less waste. So this is our site waste after 9 weeks. The contractor had this kind of old guy with a little rolled up cigarette in the corner of his mouth and a broom with nothing to do on site for 9 weeks. So completely quiet. The whole building goes together with cordless screwdrivers. So no jackhammers, no grinders, no cement mixers, no constant kind of scurrying around with masks and gloves and goggles. Very, very quiet, very, very clean process. Fewer deliveries, so an 80% reduction in construction traffic onto the site. And lightweight, so a fifth of a concrete building, which means less foundations and less impact locally. So we wrote a book about it afterwards, because there'd been so many people have been asking us questions, and because there was a recession. So we wrote a book, because we didn't have any other work to do, and it's still available on Amazon. I get about 30p if you buy one. So, and we went out and we started talking about it. And to our amazement, a lot more people were interested in it than we thought would be. So this article in the New York Times and others encouraged us to take this research and to really run with it, to begin to talk to people and teach about the research that we'd done. And to our amazement, this really kind of had produced a sort of a groundswell of interest behind this project. And this followed in London with many other projects. So this is a Lend-Lease project, Horden Cherry Lee, Alex de Rijker, Awfully Horrid, Monaghan Morris here. I mean, lots of different projects coming through. Nearly 500 projects in the UK now built in CLT. And then across the world as well. So we've worked consulting in Australia, in Italy, in Canada, Austria, on different projects as well. So really, suddenly the beginning of something. Suddenly the beginning of a new idea about how we might build buildings. A new system, if you like, of construction and architecture. So in 2012, finally, with two friends of mine, I found a site to build a house on. And with my two friends, Jason and Dan, we bought this piece of land here, and we sold our flats and our furniture and everything we had, and bought the site, got planning consent, and ran out of money. So we managed to persuade, we sold the lower ground floor here, and then we went out for tender to the builder, and we agreed a tender price with the builder, and then sat the builder down and explained to him that we didn't have any money. So we managed to persuade the contractor to lend us the money to buy the building to pay him with, so that we, and he accepted. So we, bizarrely, so we paid him back once we'd finished the building. So this building was a photographic studio for Dan here, and flats for Dan and myself and Jason. It was supposed to be me and Dan and Jason, but Dan and Jason fell out, so I had to move in the middle. But they're friends again now. But so it was all kind of, but Dan is a photographer, and Dan needed a studio which had to be a minimum of 9 meters wide, 6.5 meters high, and 23 meters long, and with no columns and no beams. So how would we produce that? How would we make that space happen and still get our flats on the top of the building, which is what we wanted? So what we did was to use the CLT, to begin to use the CLT in a way in which you wouldn't be able to use any other kind of material. So the notion that a wall in cross-laminated timber is a long beam, because if you imagine that rather than carrying the load straight down, it can carry the load all the way along as a beam. So we use the party walls between each one of the flats here as a deep beam, so like a series of boxes, if you like, that are then supported off the front and the rear elevation, which act as giant trusses either side. And that way we were able to hold the flats up above the photographic studio here and have that studio as a completely open space. So you can do that because of the light weight of the material as well. So the whole thing is really tightly tied together. 500 cubic meters of CLT. So it's about a third of the CLT per square meter that we'd used on Murray Grove, mostly because I was paying for it myself, so it's quite expensive. Completely open plan, as I say, and this is the building going up. So you can see this is the studio here. The other thing that we did is that rather than cut holes in the CLT panels, we've begun to use the CLT in terms of, where it's needed most. So you can see this is where the vertical loadings are going here, using this as horizontal here, and here as the lintels across. So rather than cutting holes out, we're actually cutting down strips of CLT and using it in that form. So this is the photographic studio in here. Hard to really kind of understand quite how massive that space is. We had, about a year and a half ago, we had the English rugby team in there doing one of those photo shoots where they all kind of jump up and go like that. And I was fast asleep up here, just above the fire alarm, just there. And I didn't hear a thing. So that's us, the first Christmas, so clad in sweet chestnut. And I think that what that building begins to do is to begin a conversation, or in my mind, a kind of, something completely different, something completely new. So if you think about 100 years ago, when people discovered reinforced concrete, when the idea of reinforced concrete came back to the fore, so you had Corbusier and the other modernists talking about a new kind of architecture. That new kind of architecture came from a new material. And we now have a new material. We now have a suite of new materials in engineered timber. And the kind of architecture that new material will begin to produce, to begin to propose, I think is what's particularly exciting at the moment. So what will these new buildings look like? So this is Dalston Lane. This is the building that we're working on at the moment, just finishing up. And this is proper. This is kind of like, this is what we wanted to do. This is high density, high rise housing, about 10 stories, 121 flats, and 3,500 square meters of offices and retail. So right in the middle of Dalston, in North London, very urban, very tight environment. If we built the building in concrete, it would have weighed 10,000 tons of concrete. In timber, it's less than 2,000 tons. 170,000 square feet, 16,000 square meters. About 800 people will live and work in this timber building, which is about, 4,000 cubic meters of timber, which is 2,500 trees. So just over 3 trees, 3.125 trees per person in this building. Now we give away one of these buildings every day and a half on the tube in London in terms of free newspapers and free magazines. So the timber that goes to make this building is given away every day and a half on the tube. So this is us. This is a CGI of the building finished. Now that building, when complete, will save 7,000 tons of carbon dioxide from going into the atmosphere. Now 7,000 tons is 24 music festivals, 105,000 cars, 12 kilometers in a car, Facebook for 3 hours, or 24 billion phone charges, or one for the 570 million pots of tea produced. So an awful lot of carbon dioxide. So you can see the building going up here. And as I said, really tight site. You can see the timber coming in here. This is us in the summer. So phase 1, which is 7 stories finished. Phase 2 at the back here, about halfway up. And this is us about 6 weeks ago. So this building will go up in just over a year, about 18 months. The whole building will go up. Yeah. So the buildings that we've been working on, this is Hackney, where we work and where we live, where I live, and the more we kind of like research, the more we've become involved with local politics, with local politicians, with the planning office, really begun to infect our borough and become part of the area that we're in. Never did I think when I was at architecture school that I'd become like a local architect, you know, like a local doctor or something. But this seems to have happened to us, or seemed to have happened to us in Shoreditch. So we now have a greater concentration of tall CLT buildings in Hackney than anywhere else in the world. We have a mayor in Hackney who is proposing and promoting a timber-first planning policy, so that all buildings in the borough must be built in timber unless you have a good reason not to build them in timber. So this is really exciting stuff. We've started working for Berkeley Homes, so the UK's biggest house builder. We built this building. 5-story, 18 parts. You know what? We built the building in 3.5. We built the entire structure in 3.5 weeks on a 5-week program. So we saved a week and a half of a program that they didn't think could be done. 100% CLT, so no concrete in this building at all, right from the ground all the way up in CLT. And now this building is being monitored. So this building is like, has electrodes all over it, inside and out. The acoustics, the thermal use, air tightness, energy use, all being monitored through the building. And also, the people that have bought these flats have also agreed to be monitored as well, quite difficult to evaluate, but monitored in terms of their well-being, of actually if they feel happier, if they think they feel happier being in a timber building. Because this is kind of an interesting thing that's coming through, is also the feeling of well-being that people are expressing to us living in a natural environment rather than in a cold concrete or steel environment. Living in an environment where, in a hygroscopic material that soaks up moisture from the atmosphere, releases moisture into the atmosphere, that is actually more friendly in acoustic terms. That the Austrians have done tests on school children. You can just imagine, can't you? So they, which monitoring their heart rate and their stress levels and their performance at school. And clearly you're able to demonstrate that children in timber schools are happier and healthier and nicer than children in concrete schools. So this understanding, this feeling of actually, that feeling of well-being, that feeling of kind of like, how do these buildings not only affect the architect, how the system not only affect the architecture, the construction process, an idea around climate change, but also the people that live there, the people that work there in these buildings, and how they're affected by this different construction system. Now, excitingly, we're starting to work on larger and larger schemes. So because of the weight of the material, because of the weight of building in this building being so much lighter than concrete, we're able to build on sites which previously weren't open to construction. So we have Kingsland Shopping Centre in Dalston, which is where the Eurostar runs. So the Eurostar runs directly under the shopping centre, which meant that they could only build 2 or 3 stories in concrete, which meant that they didn't bother doing anything. So that the Matalan has survived for years untouched in Kingsland Shopping Centre. But this gives us the opportunity to look at this site for redevelopment. So 650 homes and 35,000 square metres of commercial and residential development there. And now, this year, we've started working for Legal & General. So I'm sure everybody's heard of Legal & General or seen the umbrella sign around. 70% of adults in the UK have some level of financial dealing with Legal & General. They insure everything. You know, they're one of the biggest global funds. So they have a £750 billion fund in the UK alone. So this is a massive fund. About 3 or 4 years ago, they stopped putting all their investment in stocks, and they started buying land. And then they decided to develop some of this land. And then when they looked at development, they looked at construction, and they thought, well, that's an awful process. That's just terrible. We don't want to have anything to do with builders. So we should prefabricate them. We should prefabricate them in a factory, and if we're going to do that, we should do it ourselves. And if we do it ourselves, the best way to do that is in cross-laminated timber. And if we're going to get cross-laminated timber, then we should make our own cross-laminated timber. So earlier this year, they bought a factory in Yorkshire, 850,000 square foot factory. And by summer next year, they'll be producing 140,000 cubic meters of cross-laminated timber, which means the UK will have the world's biggest CLT producer. And we are starting to make modular homes in this factory on 14 production lines, where we're making timber homes in this factory, which we're taking to site on the back of a truck and building up into massive housing, which is just so exciting. This takes all that idea of the kind of, you know, Tony Garnier and the City Industrielle, the idea of kind of like those conversations that I'd had with Henry Ford 100 or so years ago, you know, about the idea of a production line of kind of a machine for living in, about how we can actually begin to take this arcane construction process that we've been locked in for hundreds of years out and off the construction site and into a factory-controlled environment where actually people can work undercover, where we can build buildings effectively, cost-effectively, and of high quality. So always before it's failed, always before the dream of modular housing has failed, it's failed because people have used poor materials. They've thought the only way to do this is to use lighter and lighter material, less and less material, and to build smaller and smaller housing, and to build only one type of housing. So they said, we've done modular housing, but you have to have it, and it's made of cardboard, and you can touch the ceiling, and it'll fall apart in 10 years' time, and as long as you're happy with that, it'll be okay. So that's been the previous kind of notion of modular housing. Whereas what we have here is we have a factory floor, we have our material, and we can make whatever size of box we can get down the road. So the first thing we do when we get a site is we look at the postcode, we phone up the haulage company, and we say, how big a truck can you get to this postcode? And they come back and they say, we can get a 5-meter wide truck to this postcode. So we go back to the factory, we go back to our drawing boards and say, great, we're going to make a 5-meter wide modular housing. So this one here, for instance, is 3.2 meters. This is a pocket unit. So this is a one-bed, one-person, affordable housing model in central London. So we can build these for £50,000 and have them delivered to site with all the windows, all the bathrooms pre-fitted, all the kitchen pre-fitted. And these are solid buildings. These are not buildings when you hit the wall or when you flush the loo that your neighbour can hear. These are buildings with solid 4-inch thick solid timber walls. Buildings built of timber. So this is what they look like. And you know what, so we build all this stuff in BIM. So suddenly, you know, in 13 years, we've gone from a practice that designed nightclubs to one that has just been named BIM Practice of the Year. I never thought that would happen to us. But you know what? The fascinating thing with this is, the exciting thing is that what we're drawing on our machines is what ends up on site. Now that hasn't happened for a long, long time. You know, the idea of the architects is a kind of sort of like the vague dandy at the end of the table who decides what color it's going to be, and everybody else will get on and build it. You know, that is gone. That notion is gone, because the buildings that we're building, the decisions that we're making about where the cuts are made, those are the same files that we're drawing. Those files migrate all the way through to the factory, to the CNC machine, and that's what's cut out. Oops. So this is one of the first buildings we're doing. This is in South London, Walthamstow. 1 bed, 2 modules, 2 beds, 2 modules, 3 beds, 4 modules, and these go on site here. That whole site will be complete in 6 months. Construction in 6 months, 420 flats. And we've also started to build other types of building, so not just housing. This is an office building, which we've just been instructed on in Shoreditch again. And this is headquarters for a tech company. And this building will be built from glulam columns and beams with a solid CLT core and solid CLT floor slabs. 100,000 square feet, 10 stories. The whole building is programmed to go up in 10 months from start to completion. And this building really is about, interestingly, I think it's when we pitch this idea of doing a timber building to a City of London commercial office developer, and we pitched them to do a timber building. The idea was that we said to them, well, actually, if you look at most of the companies that are going to rent these buildings, their major problem is not how much rent they pay. Their major problem is losing people, is actually training people up and having a fast turnover of staff, because people don't like working in the buildings that you've all been building for 100 years or so. You know, people want to work in nice spaces. People want to work in good, healthy, light environments. So this is completely naturally ventilated, as well as being very light and very open as a building. And we started building student housing. So this one's in Brighton for an American developer. And this one begins to talk about curves. So we're faceting the corners here with SIPS panels, with timber SIPS panels on the external facade, and then CLT floor slabs, CLT core, and then CLT shear walls through the building. We also started working in other materials, not just CLT. So also maintaining the notion that, as a practice, we're looking at low carbon technologies, or technologies that sequester, that hold carbon within them. And for Bushey Cemetery, which is just north of London, we're building this in rammed earth. So we're taking the soil from the cemetery, and we're using that soil, bringing in aggregates and sand and tiny little bit of cement, and we're building the buildings from the soil from the cemetery. So those are going up at the moment. And we're building abroad. So now we've got a project, just got planning for 2 weeks ago in Paris, and another one in the States, and another one in Sweden as well. And we've been working with the US government as well. And, you know, typical Americans, they kind of watch us doing it over here and then think, oh, that looks like a really good idea, we'll do that. And then suddenly do it 10 times bigger and 10 times faster. But in the Senate, Obama's Secretary of State for Agriculture pushed through a bill to promote the notion of tall timber buildings based on Murray Grove. So there's this little kind of building in the council estate in Shoreditch, and the notion of that building has been promoted in the Senate and put forward as a bill to promote those buildings. Oh, and we started working with other architects. So alongside architects like Renzo Piano and Richard Rogers, and we're working with Shigeru Ban. So Shigeru Ban, the Japanese architect, we're building a tower just adjacent to City Hall, across from the Tower of London, in Pottersfield Park, which is very exciting, especially because we're working with an engineer, this engineer who is a Swiss engineer who is about 150 years old. And he's like Yoda from Star Wars or something. He's kind of, and he's just a genius. And we're doing things like, so in this building, we're not using screws or nails to tie the timber together. We're using dowel, little kind of like little dowels, like in a piece of IKEA furniture. And what they're doing is we're milling the holes for the dowel, exactly the same size as the dowel. And then we're getting the dowel and we're putting it in a microwave. And you put it in a microwave for 2 seconds, take all the moisture out of it, and then it just slides into the hole and it accepts the moisture from around it, and it's locked tight. And another thing we're doing is, for the acoustic separation, is rather than using concrete or different types of insulation, we're actually just using sand. So we're building on the floor slabs, we're building boxes, and we're just filling them full of sand. And that's how we get our acoustic separation between each floor. And as the building vibrates, the sand forms, sort of forms a curve like this, which actually helps to support the vibration of the building, reduce the vibration of the building. So here we are. So this year, working on 5 stories for Berkeley Homes, finished 10 stories in Dalston, 15 stories consented in Paris, and 20 stories that we're working on at the moment with IKEA. So really exciting times for our practice. And we have 23 live projects in timber at the moment in the office, and are looking and hoping for more. But this is the photograph that we took into Hackney Planning when we first started talking to them about Murray Grove, and the notion of a kind of a future of a sustainable and environmental aware architecture. And this is the number of seeds that it took to grow the trees that built Murray Grove. Thank you. You'd really think so, wouldn't you? And you know what? We constantly are looking for problems. We're constantly looking for, what can be the issues, what can go wrong. We are constantly working with people like the BRE and TRADA and NHBC around fire issues, around acoustic issues. But honestly, it performs so well in all those situations. The real problem that we have is perception. The real issue that we have is a construction industry that has been doing it in the same way for 100 years. And to try and change that process, to try and disrupt that process, if you like, is really, really difficult. So you know what? We'll get so far, and I'll go with I'll meet with the developer, and the developer will be really excited about it. I'll meet with the planners, they'll be really excited about it. The developer will appoint a contractor to do the job, and the contractor will say, yeah, we could do that, but we could do it in concrete. And if you do it in concrete, then then there's less risk. We don't know about this timber. Nobody's, only a few buildings. So it's that kind of conversation. So it's always about perception. I'm sure that by the time that you're in practice, it'll be a doddle, and that everybody will be doing it. But but for now, I think that the rise of this technology will be exponential. So people like Legal & General and Berkeley Homes this year taking on board CLT will change the field completely. Right.
Okay, I've got 2 questions. I'll have one now, if you like.
Okay.
You talked about the timber's ability to absorb and release moisture.
Mm-hmm.
By the time it's covered in plasterboard with a vinyl emulsion, can it
That's reduced.
effectively?
Apparently so. I mean, you can imagine that is vastly reduced. The capacity of that to happen is vastly reduced, and the idea that that we would promote that by using clayboard, and that kind of thing, which we have done in my house, for instance, is will perform much better. But you still have a performance apparently in terms of moisture levels, even within drywall with regular emulsion paint. So I'm informed. But yes, I completely take your point. Yeah.
For the CLT factory in Yorkshire, would that be aiming to use timbers from the UK?
So the notion is that there will be a combination of timber from Scandinavia and from Germany, Austria, and also from the UK. So we do have forests in the UK. We have the largest man-made forest in Europe in the UK, in Kielder Valley. But the quality of the timber is not fantastic. But actually, if you imagine that a CLT panel in many ways, like an I-beam, if you have the top and the bottom layer are strong, then the central layer can be a lot weaker. Yeah.
Am I right in thinking you don't have your own engineers in practice? Are you using or working with other companies in this project?
So we have a full-time timber engineer in our office, but we do work with a number of different engineering practices. And I think that for us, one part of the process of design has changed with this material as well. I think that for a long time, the relationship between architects and engineers has been a fairly unhealthy one. You know, it's been a sort of a problem-solving relationship where the architect comes up with some sort of whimsical form and then passes it to the engineer to solve the problem. So rather than that being a kind of a collaborative, cohesive kind of design team, you know, it actually becomes one of kind of, you know, problem solver and dandy. You know, it's not.
So do you tend to sort of say to the client, we would prefer to work with this practice of engineer? Do they give you a say in that?
Yeah.
And who do you like to work with?
We work with, we do a lot of work with Arabs. We do a lot of work with Ramble in Cambridge, who have a particular kind of understanding for timber. We do a lot of work with Ingenuity, who are a smaller London-based practice who concentrate on timber engineering. We work with Technico with Matthew Wells, who was our engineer on Murray Grove. So we work with probably about 6 or 7 engineering practices. And before we work with them, we bring them in to the practice, and we talk them through a number of projects. We look for engineers who are interested and excited about the opportunities of mass timber construction, and then we really kind of will take them in, if you like. I like engineers.
We're always told about the honesty of the material. And I was just wondering, how would you justify the use of other claddings? So in a way, I mean, obviously you're not lying.
Yeah. Yeah. Well, that's a kind of it's a good question. You know, on Dalston Lane, we clad Dalston Lane in brick. So you have a 21st century lightweight structural system, and you clad it with a kind of Roman structural material, and which is completely counterintuitive and incredibly frustrating, I freely admit. And when I sat in the planning meeting, and the planner said, "Oh, it's a shame you can't do it in brick," and my client said, "Oh, I'd love to do it in brick." And I sat there between the two of them going, "No, it's crazy, you can't do that." You know, the thing is, like I was saying before, you know, one of the reasons why I started with that, the issues around climate change, and that, if you like, is the sketch. So the idea that, you know, that we can demonstrate that timber is a viable alternative to concrete and steel, that's the kind of the essence of what it is that we're trying to do. And it's an evolutionary process. Feels revolutionary, but it has to be evolutionary for it to work. You know, my concern is always that, you know, whenever you see in the magazines, you know, you kind of turn the pages of the AJ or whatever magazine it is, and you get some skyline with a massive tower coloured in brown, you know, and with an arrow that says Timber Tower. You know, you think, well, actually, is it? And is it ever going to get built? No. And then that scares me, because I think, oh God, you know what, architects are so fickle that this year it's timber, next year it'll be something else. You know, so our kind of, what we're really trying to focus on is to change the nature of the construction system, you know, change what we build in. You know, I have lots of exposed timber in my apartment, in my flat, and we continue to kind of, to do work to demonstrate that we can expose more of the timber. But the essence is, and the truth to the material in that sense, is that it's about the structure, and it's about what we build our buildings of. So yes, I agree with you, but give me some time and we'll do it better.
So just one question. You seem
Yeah.
to be focused quite on innovative ways of construction in the UK, but you said that you're bringing the wood from far away, so from Europe.
Yeah.
So are you considering the CO2 emissions embodied in bringing
Yes.
the wood in Europe,
Yes.
in the UK, sorry, and how do you justify that?
Yes. They are part of the carbon calculation. So the carbon emissions of the transport of the timber from Austria is part of the carbon calculation that we make, always. and it's still actually less than the carbon emissions of concrete that would be transported to site, because there's so much more concrete transported. So on Dalston Lane, we're 93 deliveries of timber to site, and we would have been over 800 deliveries of concrete. So, so yes, it's something that we include for, and it's something we thought very carefully about before we started building in it. The idea that we do something sustainable, and that, but in order to do that, we'd have to bring it on a truck from Austria. Felt wrong, but actually you have to start somewhere. And now that we have the factory coming up in Yorkshire, the idea that it's going to start being produced locally, we've encouraged or helped to helped an industry to form, to make cross-laminated timber. And when we built Exton Street, there were 2 factories in the world making about 50,000 cubic meters a year of CLT. By the end of next year, we'll be producing 1 million cubic meters of CLT worldwide, with factories in New Zealand and Australia and Papua New Guinea and Russia and Japan and the States and Canada. And, so it's like from where we were 13 years ago to where we are now, yes.
We tried to make the CLT using different carbon tape.
Yes. So we have a job at the moment. We have a factory in Leamington Spa, and we're making the factory from beech glulam. So using a hardwood glulam, which is, are you an engineer?
Yeah.
It's a GL70. So it's hard as anything. We're spanning 12.5 meters with a 500 mil beam. So it's good stuff. The other thing that we're working on with the same manufacturer is the notion of laminating hardwood veneers or hardwood laminates into glulams in order that we can create cellular beams as well, so that for commercial projects where we need to run services through the beams, so that we're not increasing the floor to floor, that we can run it through by framing the openings with hardwood. So there are lots of different, in Papua New Guinea, they're trying to make CLT out of eucalyptus. So, different people are doing it in different ways. In Cambridge at the moment, they're working with Richard Rogers on laminating carbon fiber into CLT in order to strengthen any connection details in joints. So I think that, we're just starting. This is this is just starting this process.
What would you estimate is the average lifespan of your CLT buildings?
Well, we're certified, like any other construction material, for 60 years with a BBA certificate, just like concrete or steel frame building is. My view is, if you build a CLT building well, we shouldn't have to worry about it. There's a church where my mum comes from in Essex that's 600 years old, built from timber. So, there's no reason why, the pagoda in Kyoto as well is pretty old. So, there's some very old timber buildings.
Seeing that so efficient on site, how much time do you save in comparison to normal concrete building?
If the building is designed in CLT, so I didn't really talk much about that notion, but we look to use as little CLT as we possibly can, and the way in which we do that is by learning what the how the architecture can affect the amount of CLT you use. So long-winded answer, but the basis of that is that because CLT is really light, wind load is always your issue. So you build robust buildings, stout little buildings. If you build with the understanding that if you design for CLT, knowing that you're going to build it in CLT, we should halve the construction time on site. We should be able to build in half the time that you can in a concrete building. If we take, which we have done, buildings that are designed in concrete, that might have some issues around, might make it slightly more complex to build in CLT, then we would generally expect to save about a third. So significant time periods.
Okay. Last question for. Oh, okay. Yeah. Okay.
going to ask about Murray Grove, which seems an eminently well-founded from a practical point of view. I still have a question about the aesthetics of its appearance, which at best seems sort of idiosyncratic. Can you say anything about its external appearance, the definition of its external appearance?
Well, why it's clad like that?
Yes.
Oh, that was just, you know.
What was designed, what was the idea behind that choice?
Well, funnily enough, when we went to planning, the planners wanted us to do it in brick, wanted us to clad it in brick. And when I said, well, why do you want to clad it? You know, and you go through all the arguments about, you know, its context and it's what people are used to. The planners said to me, well, actually, we think that there's something about a facade being broken down into lots of little pieces which makes it more acceptable to the human eye. So I was like, okay, fine, if I can do that, but with a different material, then, you know, so what we did was we took a sun path animation from around the site, and we took that up and we kind of wrapped it around the building, pixelated it and wrapped it around the building. And that was the notion behind the facade coloring. And actually, it sounds a kind of, you know, quite an abstract thing to do, and actually it came from an idea from a Gerhard Richter painting. But it sounds sort of an abstract kind of process to go through. But when you go to site and you see it in context, it works. You know, you see it on the skyline, and there's something about it just sort of fits in to the skyline where it is. So,
You haven't had any second thoughts, you're still convinced by it.
do you know what? It's a bit of a Marmite building. I can see where you're going with this, but which is fine. You know, some people absolutely love it, and like with everything I've ever built, I kind of, you know, sometimes I love it, and sometimes I can't even go near it.
Thank you.
Okay.
What kind of foundations do you have for the tall timber building?
Reduced.
Are you made out of concrete or?
Yeah, for now. For now. I like the idea of ash piles, but we're working on that.
Is it timber straight into the concrete?
No, what we generally do is, on a few projects, you know, what you need to do is you need to take timber off the ground. You know, so any failures in damp proofing or whatever, you know, it's just good practice. You look at an old, you know, shed in Switzerland, and it's always kind of taken off the ground. There's always sort of stones underneath it. So the idea is you take the timber off the ground. Usually we do that by making a flat slab at first floor level and building the timber structure off that. And that allows us to have a different program on the ground floor in terms of, you know, lobbies, bin stores, offices, whatever, you know, retail on the ground floor. So we generally do that. But we have built it where we, you know, where we have a series of 150 upstands all around the plan, and then we build the timber straight off that. But that's more complex.
I'd just like to know, if you're building, do you take the rain into consideration, like maybe the moisture and possible mold in the building, or is that not really anything that you need to worry about?
When we build the buildings, they can get wet, and what we found is, you know, if they're not protected for 2 or 3 weeks, it's fine. You know, and they will, because they're moisture, because the timber is moisture, because it's kiln dried, has the moisture, most of the moisture taken out of it. It's kiln dried down to about 8%, 8 to 10%. So that changes the cellular construction of the timber itself, the cellular nature of the timber, so it's able to actually to dry out quite easily. However, what we have found, if it's wet for a long time, so a year or so ago we had a contractor who was fighting with another contractor, and they left the building out in the snow. And we had a couple of inches of snow on top of the timber for a couple of weeks, and it was exposed for about 3 months. And we found in that situation there was quite a lot of swelling, and the timber actually just slightly changed, you know, the nature of its of the actual planks, and each floor slab swelled, and even when it went back down to about 10%, they were still swollen by about 2 millimeters. So it's not a lot, but it's, if you're building in bricks, it's still something to take into consideration. So generally, we don't foresee a problem with that. We haven't had any issues around mold. We had a building that was completed about 10 years ago, which wasn't plumbed in properly, and we had a phone call last Christmas because a floor tile in somebody's bathroom had cracked. And we went to the site, lifted up the floor tiles, and we found that there'd been no silicone around the edge of the shower. And for 10 years, the water from the shower had been going onto the wall and falling straight down onto the floor behind the shower tray. And the floor had become sodden. And for about a meter around the shower tray, we had about 20 mil of wet rot. And then beyond that, for about 200 or 300 mil, we had some dry rot around that. But it hadn't gone down below the first laminate. So what they were able to do was to scrape away all the rot, paint it with an antifungal treatment, and then lay some plywood over the top and retile, which took a day. So, you know, the leaking tap, the badly fitted windowsill, all of those things, you know, I think can produce problems in CLT, but they can produce problems in every kind of construction material. You know, so at least with CLT, you can chop a bit out and put a new bit in. So you can't do that with concrete.
Okay, last question, sorry.
What kind of spans do you usually design within?
So our rule of thumb is 7.5 meters. 4.5 meters is preferable, up to 7.5 meters. Whitmore Road is 9.27 meters as a CLT span. It depends what kind of mass timber you're using, whether you're using CLT or glue lams or, you know, Richmond Ice Skating Rink in British Columbia in Canada has a glue lam which is, I don't know, must be what, 40 meters, 45 meters, you know, so you can get some big spans.
So do you reinforce the floor base with glue lam beams?
We have done, I mean, on Whitmore Road we haven't. On Whitmore Road that's a 9.5 meter span, but it's also held by the party wall beams. So we would generally look to between 4.5 to 7.5 meter spans.
Are you happy to take another?
Yeah, no, questions are good. Questions are why I came.
I was wondering, what's your balcony detail in the city structure?
So we've done it a few different ways. We've done it where we just carry the slab straight outside, and we use the extension of the slab. Because we don't have so much coal bridging issues. It's not that there are no coal bridging issues, but they're vastly reduced. So we've cantilevered the slab, we've attached a balcony on the outside with plates, and we have internal balconies as well. And we've done all three of those, and they've all worked well. So fairly flexible.
Right, okay, last question. Really last question.
Does your orientation of the actual CLT play a role in your design and construction in a way, or is it just a building definition?
No, the orientation, so the primary load path of the CLT is the top and the bottom laminates, which run parallel. And so we try and use the CLT to its best advantage. So in the walls, we generally use it horizontally, and in the lift cores, we generally use it vertically. So we try and kind of, you know, we try to be clever about it.
Okay, thanks, Andrew.
Pleasure.
Before we close today, I have a question from our interest.
Okay. I thought that was the last question.
Right. Well, this is the last one.
Okay.
Right, I saw Murray Grove in 2010 when I just came to this country, and I met Lily there, so I was quite impressed. It was quite impressive. And then I went to Whitmore, and I went to the vibration.
Yeah.
Okay. So this is how I met with Andrew. But the question is, if you got another chance to redo Murray Grove again, what change you would make?
I had that conversation with Matt Linegar about a year ago, and Matt and I agreed that there'd be a few things that we would do differently, and we reckon we could probably reduce the amount of timber in the building by about 20 to 25%. And one of the ways in which we could do that would be to reduce the wall thickness as we go up the building. And the other way would be where we have floor slabs. It's a simple platform construction, so where the walls, the floors go on top, the walls go on top, and you build up like that. One of the issues with that is we have some vibration flanking over the party wall. So that means that we had to build up the thickness of the floor slab. So what we would do is, and what we did on Dalston Lane, is to actually have one floor slab that connects into just a fillet piece on top of this, and then another one that we reduce the floors. So anyway, lots of little kind of tricks, but we think that we would reduce the timber by about 20%.
So it's mainly because
Yeah. Yeah. So we try and get better every building.
Right, okay, thank you very much for